Good morning, students. Today we are going to discuss another important topic, that is conduction of electrolytic solution. Conductance of electrolytic solution. So before starting this topic, we should study the conduction through a metal, right? Conduction through a metal. So you studied about what is a resistance. So resistance is represented by the letter R, capital letter R. So what do you mean by resistance? Resistance means the property of a material which opposes the flow of current. That is called a resistance, and you can find out the resistance by the formula R is equal to rho into L by A, where rho is called the resistivity or specific resistance. Specific resistance. L is called the length of the conductor. Length of the conductor, and A is called the area of cross section. Area of cross section of that conductor. Suppose one wire you are taking L length and its area of cross section, right? Area, suppose R is the radius. Okay, radius you can find out by screw gauge. Okay, radius if you know, then you can find out the area is equal to pi r square. Using this formula you can find out the area, right? So resistance we can calculate it by the formula rho. This is a basic formula. So R is equal to rho into L by A. So how will you find out rho? Rho is equal to R into A divided by L. So specific resistance or resistivity is equal to resistance when the area of cross section is 1 centimeter square and the length of the conductor is 1 centimeter. Then resistance is equal to resistivity. What is the unit of resistance? Unit is ohm. Ohm, and you can represent it by like this. Okay, this is the unit of resistance. Then what is the unit of resistivity? Resistivity or specific resistance. Okay, so R ohm, area centimeter square divided by centimeter. So ohm centimeter. Okay, ohm centimeter, that is the unit of resistivity. Now resistance you studied, resistivity studied. You take the opposite of this one. Resistance opposite 1 by R. So if you take the value of 1 by R, then you will get a conductance. Conductance is represented by the letter G, and G is equal to 1 by R, and the unit is ohm raised to minus 1. Ohm raised to minus 1, or you can call the mho, or you can call the Siemens. This is the SI unit. Okay, Siemens we are represented by S. This is the unit of conductance. Okay, conductance. Then conductivity is an important factor. What is conductivity? So conductivity is equal to kappa. K represented by the small letter K, and you can call as kappa. K is equal to 1 by rho. K is equal to 1 by rho. So our equation will be, what will come? Opposite of this one. L divided by R into A. Right, 1 by rho, and which is equal to opposite of this one, L by R into, so 1 by R. 1 by R you can call as what? Conductance. 1 by R is conductance. G into L by A. G into L by A. Conductance into L by A. Using this equation, you can find out the conductivity. right? This is the equation for conductivity. Yes. Now, this is in the case of metals. Okay, in the case of solids, okay, solids are metals, okay, metals. Now, what is the equation for the electrolyte? How will you find out the conductance of electrolyte? Right, that's the next one. So, in the case of electrolyte, we can't directly measure the length and area of cross section of electrolyte. There we will use same formulas but in a different manner, okay, right? So we will see that one. This equation we need conductivity is equal to L divided by or G into L by A. So K is equal to 1 by R into L by A, right? 1 by R into L by A. So in the case of electrolytic conductor, in the case of solution, L by A, L by A is called a cell constant. L by A is called a cell constant. R is a resistance. Okay, so L by A from this equation, cell constant is equal to K into R. So this is a very important equation. A lot of NEET exam is asked. Okay, so cell constant is equal to kappa K into resistance. Okay, you can find out the cell constant value is equal to K into R resistance. K means conductivity or specific conductance. R is called resistance. So what is the unit of conductivity? So conductivity, what is the unit of conductivity? So from this equation we can find out 1 by R. 1 by R is what? Siemens. Siemens unit L by A. So Siemens per centimeter. Okay. So how much conductance is produced per centimeter? Okay, that is the unit. Siemens centimeter inverse is the unit of conductivity. Siemens centimeter inverse. In problems we need the unit. Okay, then we can understood what is the thing is given. Okay, by knowing the unit we can find out. So Siemens per centimeter or Siemens per meter. Okay, in SI unit it is Siemens per meter. You can find out the conductivity. Now, so how we will measure the conductivity of the electrolyte? That's a question. Okay, so take a glass tube. This glass tube is fitted with the two platinum electrodes connected by battery, right? Inside this, the solution, you take the solution whose conductivity is measured. Okay, take inside this. Right, so this much distance, the distance between the two electrodes, okay, that is the length, that is the length of the material, that is the length of the electrolyte. Second one is area of the electrolyte. So this is the area of cross section of this tube. Okay, so this is the area, and for a tube, okay, the cell constant is a constant. Okay, for a particular instrument it will be a constant value, right? Yes, so we know the cell constant value we know. Then how will you find out the resistance of the material? How will you find out the resistance? Okay, if you know the resistance, take inverse, that will become conductance. So how will you measure the resistance? The resistance is measured by the Wheatstone bridge principle. Okay, Wheatstone bridge principle, I think you studied in physics. Okay, physics, did you study or not? Okay, Wheatstone bridge principle. So what is Wheatstone bridge principle? Okay, right, it consists of four resistors. Okay, four resistors are there: one, two, three, and four. Right? And which one? Suppose this cell you can connect, remove this resistor. Okay, and here you connect this resistor. So this is your, you connect this wire. So you connect this wire with this Wheatstone bridge. Okay, here on galvanometer is connected. Galvanometer is connected here. So suppose this is a resistance, this value you know R1, and this you have to find out R2, this is R3, and this is R4. So R1, R3, R4, that resistance you know, resistance box is there, okay. So you can adjust the resistance and make the galvanometer current 0, make it 0. Now you measure the R2, you can measure R2 by the Wheatstone-Bridge principle, that is R1 by R2 is equal to R3 by R4. R1 by R2 is equal to R3 by R4. From this, R2 is equal to, so from this you can find out, so what will be the value of R2? From this you will get the value of R2 is equal to R1 into R4 divided by R3, right? So if you know the resistance of 3, you can find out the unknown resistance. Now you know the cell constant resistance. Now the conductivity of the electrolyte you can find out. Okay, right? So this is the way of finding the conductivity of the electrolyte. It may be strong electrolyte or weak electrolyte. Okay, any electrolyte you can find out. So this is a very important equation. Cell constant is equal to conductivity or specific conductance into resistance. Yes. Okay. Then the next one, the conductance of metals and solution. So can you tell any difference? Okay. So metallic conductance and electrolytic conductance. So metallic conductance means the conductance produced by the metal. That means through the solids we are passing the electricity and the current is passing. In the case of electrolytic conductance means the conductance produced by, okay, the conduction here, the electrons are conducting. Electrons are the current carriers. But in electrolytic conductance, ions, okay, ions are conducting the current. Then second difference, okay, when the current is passing, the change, okay, there is a no chemical change is involved in the metals, okay, no chemical reaction is occurring in the case of metals, okay, right? But when current is passing through the electrolyte, there is a chance of what? Chemical reaction, okay, chemical reaction can take place. Chemical reaction will taking place, okay, but here we are measuring the conductivity using AC current, okay, using AC current we are passing. If DC we are passing, then there will be the reaction will occur. So it can be removed by passing AC current. Then what about the which metal having the highest conductance? Do you know? Yes, it is silver. Silver having the conductance of 6200 Siemens per meter. Okay, right? This much conductance is produced very high. But in the case of electrolyte such as zero point 0.1 molar HCl, zero point 0.1 molar HCl, it is 3.91. Okay, so 3.91 Siemens per meter. So you can, so this is coming in thousands. Okay, so 1000 times. Okay, higher. So which one conduct more fastly? Metals having very high conductance comparing the electrolytic conductor. Okay, right? Yes. Then what happens when the temperature increases? When temperature increases, here the conductance or conductivity decreases. Conductivity decreases. Okay, what will happen here when temperature increases in the case of electrolytic conductance? Then here the conductivity also increases, right? So what is the reason? The case of metals, okay, the case of metals, when temperature increases, then more vibration will take place. Okay, more vibration will take place and more heat energy will produce, right? And the charge will not move fastly. When temperature decreases, the opposite effect will happen. Okay, conductivity will increase. They are called superconductors. Okay, helium is behaving as such a material. Okay, then here if you see temperature increases, then the conductivity will also increases the fast. Okay, they are moving fastly. So these are some of the, then in the here valence electrons, here a lot of things will depend. Okay, right? Then here the electrolyte, so viscosity, so viscosity increases, then the conductivity decreases. Viscosity decreases, then the conductance will increase. Okay, then here a lot of interactions will come. Interaction means the ionic interaction, solute interaction, solvent interaction, solute-solvent interaction. Okay, that everything will matters the electrolytic conductance. But in metallic conductance, there is no such a variations are coming. Okay, so these are the difference between the metallic conductance and electrolytic conductance. Okay, right? So these are some of the differences. Now we are moving to the electrolyte, okay, electrolytic conductance. So electrolyte means the substance which produces ions when they are in solution or in molten state, okay. That is called an electrolyte. For example, what is a very weak electrolyte, okay. What is very weak electrolyte? NaCl solution or molten NaCl. They are example for electrolyte. Electrolyte you can classify into two types: strong electrolyte and a weak electrolyte. So strong electrolyte means they are very strong. Okay, that means they dissociate. Okay, they dissociate into more number of ions in solution. Okay, so here, okay, 99% or 100% is ionized form. It is in the ionized form, full of ions only. But in the case of weak electrolyte, there is very less only. Okay, 5 percentage. Okay, 5 percentage or 10 percentage. Okay, 5 percentage only they are ionized. That means 95 percentage is unionized form. Unionized form. Right, when you are diluting, more number of ions will form. Okay, when you are adding more water, then more ions will form. right? In strong electrolyte, it is already ionized form, so dilution will not help to form any more number of ions. Okay. Yes. Now we will discuss about the conductivity with the dilution. Dilution. Okay. For weak electrolyte and strong electrolyte. So what do you mean by conductivity? So we are talking about the electrolytes. So conductivity means, how will you define conductivity? Okay, right? So conductivity means it is the conductance produced by unit volume of the solution. Okay, so that means suppose you are taken on solution. Okay, on solution here. So how much? So you have taken on solution here. So per centimeter cube per volume. Okay, in 1 centimeter cube of volume, how much conductance is produced by that electrolyte? It is called what? Conductivity. So for weak electrolyte, if you are adding, diluting, more water adding, then ions increases, but the volume, suppose initially you are taking here, for weak electrolyte there is a one ion is present. Okay, one ion is present, right? For two ions is present. Okay, one and one. Okay, two ions are present. So two ions are present. You are diluting, more water is adding, right? More water is adding, right? And so here water will come and the ion will move to there. Now it is decreased to one ion. So the conductivity will decreases when you are diluting. So dilution increases conductivity of strong or weak electrolyte, it is decreasing. What about for a strong electrolyte? For strong electrolyte, when you are diluting, okay, dilution you are doing. So same thing only. Suppose here is okay, you are taking 1 centimeter cube, there is a 6 ions are present. When you are diluting, okay, the more water you are adding, okay, so water is coming, the ions are moved away. So conductivity decreases. So this is the case of dilution. For strong and weak electrolyte, the conductivity decreases with the dilution. So that thing you have to remember. Now another thing is there, that is called a molar conductivity. Okay, molar conductivity, that is very important. Okay, so what do you mean by molar conductivity? Molar conductivity. So molar conductivity you can represented by lambda m. So molar conductivity means it is the conductance or conductance produced by 1 mole of a solution. Okay, so it is not depending on the volume, it is depending about 1 mole. Okay, how much ions are, how much conductivity is produced by 1 mole of a solution. That thing. Okay, 1 mole of a solution, how much conductance is producing? That is called a molar conductance. 1 mole of a, so 1 mole of substance or 1 mole of solution, how much conductance producing? Conductivity producing, that is called molar conductance. Okay, that is called molar conductance. Now we are going to see the variation. Okay, so variation of molar conductance. Variation of molar conductance with the dilution. So first we are going to discuss about the strong electrolyte. Strong electrolyte. So you know about strong electrolyte. So it is highly at first enough. Okay. Suppose you have taken on strong electrolyte HCl, you have taken 1 mole of a electrolyte. Okay. You are measuring the conductivity. Okay. Conductivity you are measuring. Then adding water. Adding diluting, again measuring the conductivity and plotting. So when you are adding water, so dilution increases number of ions. For strong electrolyte, it's already 100% ionized form, so the number of ions are not increasing, but the distance between the ions separation increases. As a result, the conductivity will also increase, molar conductivity will increases. Okay, so it is not depending the volume, the conductivity decreases, but the molar conductance. So don't, so dilution increases, molar conductance increases with the dilution. So dilution increases, molar conductivity of strong electrolyte increases gradually. Okay. So if you are plotting a graph connecting molar conductance lambda m, okay, molar conductance lambda m against concentration. So when you are going from left to right, the concentration increases. So when you are moving from left to right to left, the dilution increases. Okay, dilution increases. So suppose at first you got here on value, okay, second value, third value, fourth value, and four values you are diluting, more diluting. That means decreasing concentration. You got four values and you connect these, draw a graph. You will get a line like this. Okay, dilution increases, that means concentration decreases, the values increasing, gradually it is increasing. So what will be the conductance at infinite dilution? Infinite dilution means maximum diluting, then you are measuring the conductivity. Okay, you are measuring the molar conductivity, sorry, you are measuring the molar conductivity. So graphically you can find out by extrapolating this one with a y-axis. So this value, okay, here you will get a value and this is called a lambda 0 m. So lambda 0 m is an important quantity. It is called limiting molar conductivity. Limiting molar conductivity. So limiting molar conductivity can be defined as the conductivity produced at infinite dilution. That means when the concentration approaches to zero, what will be the molar conductivity? That is called a limiting molar conductivity. So this is the graph for a strong electrolyte. So for strong electrolyte, when the dilution increases, molar conductivity will increases. What about a weak electrolyte? So suppose you are taking acetic acid. Okay, acetic acid you have taken CH3COH. Acetic acid you have taken. So at first you take 1 mole of a substance, prepare 1 mole of acetic acid solution, measure the conductivity, then you add water, diluting, then what will happen? Molar conductivity will increase or decrease? There it will increase. Okay, molar conductivity will increases. Why? Because when you are diluting, there more number of ions will form. More number of ions will form. Here it is not depending the volume. Conductivity means it is depending volume, but here it is 1 mole only. How much water you are adding also no problem. Here 1 mole. 1 mole of a substance, how much conductivity is producing? That is called the molar conductivity. So when dilution increases, both strong and weak electrolyte, the conductivity, molar conductivity will also increases. Okay, right? If you are plotting a graph, if you are plotting a graph, molar conductivity and square root of concentration, so you are measuring, okay, right? So the values gradually increases. At a particular moment, it will get sharply increases. Okay, so you will get a graph like this. So see, so it is when you are diluting, it is slowly increasing. At a particular point after, it is just like a rocket. It is increasing very sharply. Okay, very sharply increases. So you compare these two graphs. Here, how will you find out the limiting molar conductivity? How will you extrapolate with this y-axis? Is it possible? No, it's not possible. Okay, right? You can't extrapolate the graph. So you can't extrapolate here. So here, how will you find out the molar conductivity, limiting molar conductivity? So here we will find out using Kohlrausch's law. Okay, Kohlrausch's law, we can find out the limiting molar conductivity of a weak electrolyte. Strong electrolyte also you can find out. Okay, mostly we can use for the weak electrolyte. So here for a strong electrolyte, there is another formula is there. That is lambda m is equal to lambda 0 m minus a e raised to 1 by 2. Okay, lambda m is equal to lambda 0 m minus a c raised to 1 by 2. Okay, this equation is called a Debye-Huckel-Onsager equation. Okay, so Debye-Huckel-Onsager equation. So Debye-Huckel-Onsager equation is used to find out the molar conductivity or limiting molar conductivity of a strong electrolyte. Okay, now we will discuss about Kohlrausch's law. Okay, Kohlrausch's law we will discuss, very important law, right? Yes. Molar conductivity can be found out by a formula lambda m is equal to 1000 K divided by m. So molar conductivity is equal to, so molar conductivity means it is the conductivity produced by 1 mole of a solution. Here K is called conductivity of the solution. Then M is called molarity. Okay, molarity of the substance. Okay, what is the formula? What is the unit of lambda M? You see, conductivity we studied Siemens. So conductivity it is Siemens centimeter. Centimeter is to minus 1. Molarity means mole per liter or mole. Centimeter is to minus 3. So this is equal to Siemens centimeter raised to minus 2 mole raised to minus 1. Okay, Siemens centimeter raised to minus 2 mole raised to minus 1. So this is the unit of molar conductance. Okay. Yes. Now we will discuss about Kohlrausch's law. Okay, Kohlrausch's law. Kohlrausch's law of independent migration of ions. Of independent migration of ions, because it is not depending on the ions. Whatever you have taken at first, it is not depending. What are the ions present at last? Okay, only that will depend. Okay, right? Okay. So Kohlrausch's law states that the limiting molar conductivity of electrolyte, of any electrolyte, it may be strong or weak, okay, electrolyte can be represented as the sum of individual contribution of anion and a cation of the electrolyte of the electrolyte. So it means that, okay, so at a infinite dilution we can find out the molar conductivity. It will be the sum of the anion and cation present at that electrolyte, and it is not depending on the other electrolyte. Okay, now suppose you want to find out the limiting molar conductivity of NaCl, which is equal to the limiting molar conductivity of Na plus ion and limiting molar conductivity of Cl minus ion. See, so this is the limiting molar. So this is capital lambda. So this capital lambda represent the conductivity, okay, limiting molar conductivity of electrolyte. The small lambda, this also lambda only, but small lambda, it represents the conductivity, molar conductivity of the limiting molar conductivity of the ions. Okay, that's a difference. This small lambda represent the ion and capital lambda for the electrolyte, right? So for a generally we can represent lambda 0 m of any electrolyte. This is equal to lambda 0 of, so suppose there is a, this V plus represent number of ions, okay, plus V minus of lambda 0 of minus. So anion and cation, how many ions are present, that also depending. So we will discuss this by doing problems. Okay, so thank you for watching.